All right, so we're going to talk about a cola machine at school, which doesn't exist, right? Because we don't have pop machines here anymore, but pretend. And we're going to read through this. We have not done a lot of reading in this class yet. So when we do this, there's a couple ways I do it. A lot of times I'm going to ask for a volunteer to read one or two sentences, and then I'll ask that volunteer to pick somebody else to read after them. But I do recognize that some people aren't super comfortable reading, especially in front of a group of people. So if you get picked and you don't feel up to it, you're allowed to pass. You just have to pick someone else. Okay. I'll encourage you to try. If you're a little nervous about it, give it a shot. That's going to build up your confidence over time. But if you're just like, I'm not doing that today, that's okay. Just go ahead and pass. So, is anybody willing to be bold and start us off on our first sentence? Come on, who's going to do it? Please, please. Oh, thank you so much. And I'm sorry, we should introduce you. I'm sorry. Teacher Richard. All right, thank you. We're going to start at the cola machine. Thank you so much. All right, so let's work through these questions together. We're going to talk about inputs and outputs. We've been talking about equations having inputs and outputs. So machines have these too. So let's write this down over inputs. We got a little space here. Describe to me, what are we putting into this machine? Money. Yeah, it's not going to work without money in it. There's something else important though that we have to put into a machine. You got to push a button, right? And for our situation, that button's kind of the key part. That's going to be our key input. Yes, machine's not going to work unless you put the money in it. I guess you got to plug it into the wall too, right? But the big thing is going to be the button. All right. And what's the output of this machine? Soda's coming out. So when we talk about our input and output, we're going to be talking about what button do we push and what's coming out of it. All right. So I like to read part B. Does anybody want to volunteer for part B? Part B, while buying, and you can just read one sentence if you want, or you can read the whole thing. Are you willing? Okay, start with while buying. Thank you so much. We got a key word here. I'd like you to circle this in your notes because this is going to come up quite a bit in our lesson today. Consistently. Does anybody want to take a shot at defining that word? What does that make you think of when you hear consistent? Regular, a pattern. What else? Those are both great. What else do you think of when you think of consistent? Like sticking to a schedule? Yeah, absolutely. Someone came up with predictable earlier this day. I thought that was a pretty good one, right? Somebody who consistently does their assignments. Like there are some of you in here that every single day you're getting a full credit stamp because you got your assignment on time. You're consistent. And I can predict with a lot of certainty that when we come in on Friday, I'm going to be stamping you again, right? So if something is consistent, you can kind of predict it. It's regular. It's got a pattern to it. All right. Are we feeling good about that? All right. So let's fill this out. What did we input? What did Ms. Whitney input the first time? Lemon twister. Do you guys okay with us abbreviating so we don't have to write out all those words? We don't have much space anyways. She pushed the lemon twister button. What'd she get out? Lemon twister. All right. And then the second time she went around, what was her input? She pushed the lemon twister button. What did she get out? Blast. So looking at that table, can you tell me, is this machine behaving consistently? What do you think? Yes or no? Show me a thumbs up, thumbs down. What do you think? I see a lot of thumbs down. So where it's not consistent. And they do say why or why not. How would you put that into words? This is the trickiest part of math, is kind of describing the why. Anybody want to give that a shot? It's not consistent because Yeah, sometimes it does one thing, sometimes it does the other, right? And it's the same button, right? Same button sometimes gives you one thing, sometimes gives you something else. That's how I'm going to write it down. Same button. And can you remind me, was the button the input or the output? The input. So the same input sometimes gives one output and sometimes another. That's not a complete sentence, but we're getting the main idea down there. All right. Do you mind picking someone to read our next one? And if you don't know names, you can just point. And remember, they're allowed to pass, so there's no pressure here. Okay, are you willing? Okay, can you pick someone to go then? Are you willing, please? Thank you so much. We're going to start with Wen Brandy.
Sometimes we don't set it to be different and push the second button flat. E2 would be the kind of flat is the machine, but
there's that word again, consistently. All right, so this one's a little weird because there are two different buttons for the same thing. Did I read that correctly? Have you ever seen that on a soda machine? Like there's like two Coca-Colas and then, yeah. Not too uncommon. So the input, we're going to have to distinguish between the two different blast buttons. So I'm going to call the first one blast 1. Or you could call it blast A or whatever you want to call it. So Brandy pushed the first button. And what was her output? Blast. She got a can of blast. And then Miguel decided to push the other blast button. Blast 2. What'd he get? Blast. Is this consistent? I'm curious what your gut instinct is. Guys, remember, we're just learning this right now. So if you're wrong, this is a safe and okay place to make mistakes. So can you guys give me a thumbs up? What's your gut instinct telling you? Consistent, thumbs up, inconsistent, thumbs down. Or if you want to go in the middle, I'm okay with in the middle here. Anybody going thumbs up? Down? I've got a few people in the middle. Okay. Does anybody want to tell me why you're thinking what you're thinking? Anybody want to be bold? It's giving it, it's a different, they'll have two buttons with the same thing. So the question is it predictable, right? Is there anything unpredictable about this? If I push a blast button, knowing what we know right now, would you predict, would you feel confident predicting what you would get? As opposed to this one, we said this was not predictable because we saw two different things. So this one's a little tricky. I don't know. If you're in the middle, I'm kind of with you on in the middle. I don't really know if it's going to be consistent or not because we only pushed each of these buttons once, right? There's a chance that we could come back and hit one of those buttons and get something later, something different later. But based on what we know so far, if you had to go one way or another, consistent or no, what do you think? I don't think there's really a wrong answer on this one. This is a margin case. I'm going to go consistent for this one. I'll go consistent for this one. You do you, though. I think you could back it up anyway. Did you have something to add? Right. No, I agree with you. So consistent, I'm going to do consistent, maybe. Yeah, so if we wanted to be thorough about this, if we wanted to expand our experiment, then what would we need to do? We need to push those buttons each couple more times and see if we're feeling confident that we're getting the same thing each time. So we don't really know. There's nothing, I don't know for sure that it's not consistent, but I don't know for sure that it is. It's kind of a maybe. Okay. All right, here we go on the last one. Can you pick somebody to read our last one, please? And if you don't know a name, it's okay to point and smile. And remember, no pressure because they're allowed to pass. So, are you willing? Can you start out with, I think this is Lutfi. That's how you pronounce that. Awesome. Thank you so much. Much appreciated. There's that word again. All right, fill out that table for me. Fill out the table. We had kind of 2 people and then sort of a group of people. Let's see, Lutfi, input, and output. Taisha input slurp, output twister. And then Taisha kind of hung around for a little bit and noticed that everyone pushing slurp, output lemon twister. Okay. All right, I'm about to ask you a different question than what's on the paper. Okay, this is not what they're asking us on this paper. Is this machine working properly? No, it's not. People are pushing one button, they're getting something other than what they asked for. Okay, so it's definitely not working properly. However, is it functioning consistently? Consistently wrong, but it is consistent, right? It's predictable. If you were to walk up to this machine right now and you push that slurp button, what are you going to predict you would get out of it? Lemon twister. And you're fairly certain of that. So I would say that this one is being consistent. We actually have some good evidence of that. And why? Well, when we push the same button, we're always getting the same thing, right? So I'm going to write that the same input always gives us the same output. Right. So our learning goal today is about these things called functions, and that word hasn't come up yet, but we've been talking a lot about consistency. Now we're going to study this thing called functions, and I'll tell you that they come up throughout Algebra 1 and Algebra 2 and pre-calculus and calculus, so they're kind of important things. If you had to take your best guess right now, do you think that things that are functions are going to be the consistent things or the not consistent things? What would be your best guess? Consistent? Does it seem like consistency is kind of important in math? I'd say it's probably one of the most important things in math, right? When we do something in math, we want to be able to get the same results every time, right? That's kind of what sets math apart from a lot of the other fields of study. And one of the things that I love about it is that there's not a lot of guesswork, right? We do the same thing, we get the same results. So what we're really looking at here are examples of functions. And I would say that this first one is not a function because it's behaving inconsistently. The second one, jury's still out. We need to do a little more testing, but this third one is going to be a function. So we're starting to develop an idea of what is a function and what's not a function. So if you flip over on the back side here, I'm going to challenge you to take a couple minutes and look at these 3 tables. And I want you to think of these kind of as 3 other vending machines. This first one is clearly a candy machine. The second one has just numbers on it, but kind of think of it the same way. You've got inputs and outputs. This is the button you're pushing. This is the thing that's coming out. Okay, for these 3 machines, I want you to try and decide which one of these are functions, which ones are being consistent, and which one are not functions. Okay, I'm going to give you about 5 minutes. I would love to hear some conversations happening in your table partnerships. So talk it over with the people next to you. If you want to kind of work independently for a moment and then spy on your neighbors and have a conversation with it after, that'd be a good way to do that too. Okay, let's take about 5 minutes and see what we can come up with. I'm going to come around and chat with a few of you too. All right, so our first table here, our first machine. Do you see any problem inputs? Do you see any inputs that are not doing the same thing all the time? What's the one you're seeing? The 2s. The 2 button sometimes is giving us M and N's, and sometimes we push a 2 button and we get duds. So if you had to predict, if you were planning on going up there and pushing the 2 button, could you predict which one you were going to get? No, because it's not being consistent. So is this a function or no? This is not a function. Go ahead and write underneath there, not a function. All right, now these other 2 tables just have numbers instead of candy or soda, but it's the same idea. And I want to warn you, I'm actually going to encourage you. There is a really awesome mistake that I'm hoping someone's going to make here when we talk about these next 2, okay? Because it comes up a lot. It's super common, and if someone is brave enough to make this mistake, we're all going to learn from it, and that'll help us all avoid it in the future, okay? So let's talk about this second one. Do we see any potential problems in this second one? The outputs of -3. So you're focusing on the outputs here. So I've got an output of -3 here and another output of -3. And do they have the same input? No. Is that a problem? Is that a problem? Now I want you to think about our soda machines, okay? We always go back to the soda machines. You're going to remember these soda machines for a long time. Would we ever run into a situation with the soda machine where we had 2 different inputs? Remember, those are the buttons. So I got 2 different buttons that are going to give me the same soda, the same output. We actually have that, right? We have a machine that has 2 different blast buttons, and you always get blast out of it. Is that consistent? It is consistent. Actually, that's okay. It's okay to have 2 different output or an input with 2 different, sorry, I'm getting this backwards. It's okay to have an output with 2 different inputs. That's all right. That can still be consistent. So thank you. You made my favorite mistake. That's awesome. And then we all get to learn from it. This is okay. This is actually a function. There are no inputs that are giving us 2 different outputs. Okay. I'm going to make myself a note here. It's okay to have an output with 2 inputs. It's the other way around that we got to worry about. Thank you for that. So it's really easy to get that rule flipped around, and I'm glad we got that out of our system early on. Yeah. Called it. All right, have a good day. All right, how about the last one? Any issues you're seeing here on the last one? What are you seeing? Are you looking at the input of 2 or an output of 2? The output of 2. I only see one output of 2. The input of 2. Okay. Yeah, I got an input of 2 that sometimes gives me 9 and sometimes gives me -8. That's not consistent, is it? I couldn't predict what I'm going to get if I push that 2 button. Sometimes it's going to give me 9, sometimes -8. So this is not a function. All right, so I feel like we're starting to get a good idea of what a function is and how to detect them and how to detect when something's not a function. This next part's going to be, this is going to be the toughest thing I ask you to do all week, okay? And it's often the hardest thing to do in math in general. You've got a good conceptual understanding of what's happening. I am going to challenge you in this space right here to put it into words. I want you to try to come up with a rule that tells us whether something is a function or not. Now, there's a couple ways you can tackle this, so I want to give you a couple sentence stems to get you started. One way you could do it is you could start by writing a rule that says it is a function if, and I'll let you fill in the end. That'd be one way to do it. The other way to do it would be to kind of do the inverse of it. It is not a function if. Pick one of those, the one that you feel would be the easiest to put into words, and see if you can complete that sentence. And if you're able to do one and you're feeling confident, my challenge would be to try and do the other. See if you can write me a definition of both something that is a function and something that's not a function. Give that a shot, and when you get it done, I want you to spy on your neighbor and see what they got. Which way did you try? Not okay. Yeah, and a lot of it's funny that in math, a lot of times it's easier to write a definition by talking about what's not that thing than what it is. And I think this is a good example of that. All right, I'll give you another minute here, and then we're just going to get some. I'm hopeful that we'll get some bold, brave people that'll share what they wrote. And this is again, this is super challenging. So we may need to do a little tweaking. We might need to combine some things together. We're going to help each other out and come up with some good, solid definitions here. All right. Does anybody want to be bold and get the ball rolling? Get us started. Which one did you do? The is or is not? The is. All right. Lay it on me. What do you got? It is a function if each input has a different output. It is a function if each input has a different output. Does that work? I think we're really close on that. I think we could maybe make one small change that would make that a perfect definition. Because does each input have to have a different output? Remember the blast button? We had two different blast buttons, but they had the same output, right? But I like the first half of it. In fact, I'm going to put that down. If each input has, what's a small change we could make to that? Instead of saying has a different output, what could we say? Has a consistent output. I like that. So we could kind of combine those together. It is a function if each input has a consistent output. That's great. Hey, that's some good teamwork, guys. Nice work. Nice work. Did anybody have something different for it is a function if? There's other ways we could say it too. It is a function if each input has, how many different outputs can each input have? Only one. So we could also write it is a function if each input has only one output. All right, who wants to be bold and get us started with the is not rule? It's not a function if, are you willing? No, okay. Sorry, it's a good one. No, okay. Anybody have a good one for is not? What do you look for? What was the first thing you noticed about this first table that told you it was not a function? What do you look for first? So you're focusing on the inputs, right? And you're looking for an input that has, can you just repeat? So it's not a function if an input has two different outputs. Yeah, it's not a function if an input has, and you said specifically two, could it have 3 or 4? How about more than one? I like more than one. I get, yes, has more than one. Or we could say 2 or more. Why don't we go with that? Because you said 2 different outputs. I'm going to say 2 or more different outputs. Let's go a little cut off. Thank you for letting me know. Sometimes I lose track. All right. You guys are doing great. Hey, there's one more thing I want to show you here, and then we're going to flip into our blue packets and get some good notes down here. You're doing awesome today. Thank you for your attention. Could you guys focus with me on this spiral graph right here? Okay. Have a look at this spiral graph. Let me get zoomed in a little bit here. And I'm going to give you a little bit of a challenge here. First of all, can you find me where +1 is on the x-axis? Where's +1 on the x-axis? Are you looking right here? Right there? +1 on the x-axis. Okay, here's my challenge. Can you find me a point that is on the spiral that would have an x coordinate of 1? I'm looking for a point that is on the spiral that has a x coordinate of 1. If you can find it, go ahead and mark it on that spiral. Spiral has lots and lots of points going around it. Can you find me one that has an x coordinate of 1? This point over here that I'm pointing out right here does not work because it has an x coordinate of -2. Can you find me a point that has an x coordinate of 1 though? Can you find me more than one point that has an x coordinate of 1? How many points are you seeing that have an x coordinate of 1? 2, 3. I'm seeing 3. Any more than 3? I see 3 also. Here's one of them. Would you agree that this point right here has an x coordinate of 1? Its y coordinate looks like it's about 2, but the x coordinate is definitely 1. Can you find me 2 more points that also have an x coordinate of 1? Mark them. Are those the 3 points you were looking at? Those who were saying 3 a minute ago? All right, now I want you to remember something for me. X's are inputs and Y's are outputs. Is this a function, yes or no? I'm going to go back to our definition here. We say it is a function if each input, so if each X has a consistent output. So we have an input of 1 here. What's my output? It's about 2. This also has an X value of 1. Does it have a different output than this one? It's got a different Y coordinate, doesn't it? This got a negative Y coordinate. It looks like negative 1.3 or something. And this one here, does it have the same output? No, it's got a different output. Is this a function? It's not a function. This is not a function. So make this a little bit easier on you. There's this cool test that you can do with a graph to determine it's a function. Has anybody ever heard of the vertical line test before? So here's how it works. If you can draw a vertical line that crosses your graph in more than one spot, anywhere on the graph, if you can draw a vertical line that crosses in more than one spot, then it fails the vertical line test and it's not a function. So I could actually draw another vertical line right here that crosses in 4 different places. This is really failing the vertical line test, but it's just got to cross more than once. Like over here, it's only crossing twice, but that's enough to fail it. That's not a function. Look at the next graph over. This is, does anybody know what type of graph this was? Somebody knew this last period and I was really, it is a wave. It's a particular type of wave. Do you know the name of it? Starts with an S. It's a sine wave. How did you know that? Oh, cool. Okay. That's awesome. That's awesome. Yeah, it's heavily involved with sound and music, right? That's cool. All right, it's called a sine wave. You'll learn all about them in a few years. Look at this graph though. Do the vertical line test on there. Is there any place I can draw a vertical line that's going to hit that in more than one place? It hits only once there. If I move over here, it's only hitting once there. Is there any place where it's going to hit more than once if I keep the line vertical? No, so it passes. This is a function. So if you can draw a line and it never hits a vertical line, it never hits more than once, that's a function. The first graph, we skipped over this because this is kind of weird. It just has a bunch of dots. Would this pass the vertical line test though? Can you draw a line anywhere that's going to, a vertical line that's going to cross through more than one of those dots? No, so it passes. This is a function. All right, and our last one here, well, this is a table, going back to a table. Let's see if we can apply our rule here. It is a function if each input has a consistent output. It's not a function if an input has 2 or more different outputs. I got a repeated input here of -8. Is that a problem though? It's consistently giving me an output of 11, so we're okay. This is a function. All right. Folks, you're doing so good today. I just want to remind you what our whole goal was in this whole business. Our learning target for today was to define a function. Do you feel like you have kind of an idea in your head of what a function is? And maybe you could put it into words if you had to. Do you feel like if I gave you a situation involving a candy machine or a soda machine, you could tell me whether or not it's a function? Do you feel like if I gave you a table, you could tell me whether or not it's a function? Yeah, do you feel if I give you a graph, you'd be able to tell me whether it's not a function? If you do all those things and you're doing fantastic, what it is time to do right now is to take all this knowledge that we've got in our heads and get it in our notes. Okay, so let's get those packets open, please. We started taking some notes on function notation, and it's a whole section on functions. I think this would be an excellent place for us to put our definition of a function. All right. We're going to work through this together, but I want to get some input from you guys. Remember, the reason we take notes is to help future us remember the things that we know now, because we know you're going to forget stuff over time. That just happens. That's the way our brains leak. Okay, so at some point in the future, you're going to want to know how to do this stuff that you really understand well now. We need to give ourselves a reminder that we can use in the future to help us out here. So what kind of things would be useful for us to put in our notes about what we did today? One of our learning targets was to be able to define a function. Was there anything that we wrote on our handout today do you think would be a good idea to have in the notes? The definitions, we wrote some pretty good definitions today. Do you think it would be worthwhile to copy maybe one or both of those onto here? If you think that's going to be a good idea for you, go ahead and do that. We wrote a definition for if it is a function and for if it's not. We actually have a couple different versions of those. So if one of those works better for you, maybe copy that one into your notes there. Or if you think both would be helpful, put them both in there, your choice. If it were me, I would probably put them both in. In fact, these are my notes, so I am going to do that. But I want you to choose what's going to work well for you. You are more than welcome to just copy my notes off of the screen, but this is my notes. I'm doing what's going to work well for me. You do what's going to work well for you. So I'm going to put some definitions in here for both. Ooh, and passes vertical line test. All right. Some of us are finishing up here. What as you're finishing those who finished up writing the definitions down, what else might be a good idea to have in our notes? Examples are kind of helpful sometimes, right? Just like that, the words are nice, but sometimes it helps to have something to look at. If you were going to do an example, like we did a bunch of tables today, we could probably come up with a table example. Do you think you would just do one example, or do you think you'd do 2, 3? How many do you think would be a good number for us? 2. And if you're going to do 2, why specifically 2? That's a good idea, right? Have one that is a function and one that's not to make it kind of clear. Yeah. We'll get those in a minute. I'll give you my packet in a minute. You can get them copied down. I need this space because we're gonna make. I'm following your example. We're gonna do 2. I'm gonna do 2. You do whatever you want. I'm gonna do 2. I'm gonna do 2 tables, and let's do X, Y. And you said one that is and one that's not. I think that's a really good idea. And I want to pick something this time that's different from what we've done. I'm gonna, you know what? I'm gonna do a not function first. I don't know why. I'm just feeling like. So basically, I just need to pick a bunch of random X and Y numbers to fill in this table. Now, what needs to be special about my X values that are here? If it's not going to be a function, what do I need to have happen in this column? I need to have something duplicated, right? Something's got to be in there twice. Someone pick a number that I can use for my duplicated input. 3. All right, I heard 3. I'm going 3. I'm going to do a 3 here and a 3 here, and then I'm just going to make up a couple other numbers, 8 and 7 and 0 and 1. I don't know. The really important thing, though, when I go to my Y column is what? We don't want anything repeating. Are we allowed to have repetition in the Y column? We are allowed to, right? That was our favorite mistake. So the 3s, what's got to be special about my Y values for the 3s? They have to be different, right? You got the same input that's got to give us different outputs. If it's not going to be a function, we got to have different. So give me 2 numbers for my 3s. 0.2, I like that. 0.2 and 2. All right. Those are different. And then the rest of them can be whatever we want. Negative 12 and 42 and 8,014. I don't know. But really the important thing is that we've got 2 inputs, or an input, single input 3, that has 2 different outputs. That's not a function. Now I'm going to be kind of tricky about how I do my other example here. I'm going to actually choose to use the same inputs, and I'm going to have that 3 repeat itself again. Because we saw some examples where there were some repeated inputs, but they were still functions, right? I think the last one that we saw on our handout had -8 was repeated, but it was still a function. This time it's 3 that's repeated. What needs to happen with my Y values for these 2 3s if it's going to be a function? They got to be the same. It needs to be consistent. What do you want our Y value to be for 3? 11? Like it. So, but we need 11 on both of those. And we got to make my favorite mistake today, and I think it would be good for us to get that mistake in our notes too. The mistake that a couple of us made and that we all learned from was we were thinking that you weren't allowed to have repetition for the Y values, but you actually are. So I'm going to do another Y value that's repeated. I'm going to put 9 in here a couple times. And then I'll just make up a couple other numbers for the rest. And I'm just going to make a note here that it's okay to have repeated outputs. Right? It's a common mistake to think you're not allowed to have anything repeated with a function, but it's actually okay to have repeated outputs. That's really hard to read, and I apologize for my awful handwriting. The first what? This is a little star that says okay, and then I have an arrow next to it, but it all sort of blends together into a big red lump. I'm sorry for that. But what I'm trying to show is that it's all right. It's not a problem for us to have these 2 9s that are going to different inputs. It's when you have the same input that's going to 2 outputs that causes the problem, right? And it's easy to make that mistake and flip it around. So I think it's good to have that mistake right there in our notes. That'll remind us to check for that mistake later on in case it comes up. You know what also would probably be a good idea, example-wise? What else? Maybe some graphs. Do you want to do 2 graphs again? Something that is and something that's not? You think that's a good idea? Yeah, I think that's probably a good idea. And we'll show how one of them passes the vertical line test and the other one doesn't. I have some pretty artistic people in here. Can somebody describe me a shape that would fail the vertical line test? A star would fail a vertical. Let's see if I can pull off a star here. Ooh, pretty good so far. I kind of lost it at the end there, but that would fail a vertical line test, wouldn't it? If I drew a vertical line, I could draw a vertical line that's going to cross in more than one place. Is that a function? Not a function, because it fails the vertical line test. And I'm going to draw a little arrow here to my fails the vertical line test. And then I'll come up with a graph that is a function. You guys have, those of you who've been doing your assignments, you've done a lot of graphs in this class. What is the most common type of graph you've done so far this year? The one that I have in mind starts with a P. Parabola. You graphed a lot of parabolas, haven't you? Is a parabola a function? Yeah. You're right. In this class, our parabolas are always going to open upwards and downwards, which means it would be a function. This passes a vertical line test because no matter where I draw my vertical line, it's only going to touch in one place. So this is a function. All right. All righty. Ooh, horizontal line test. So there is a horizontal line test. We actually, oh yes, yeah, that's another good example. Actually, I'm going to put that in there. Thank you. Yeah, I think that's another one. So one of the most simple type of functions we can talk about would just be a horizontal line. That is a horizontal line. Is it a function? Totally. It would only pass, it would only cross in one place. Thank you for that. There is such a thing as the horizontal line test. We just learned about that in pre-calculus a couple of lessons ago. So it is, and it doesn't test if it's a function, it tests whether the graph's inverse is a function. You'll learn all about inverses in algebra 2. All right, you guys did so good today. Thank you so much for your attention. We've got some time now for us to work